Carl here from lunchboxsessions.com, and welcome to part 2 of troubleshooting issues with cylinders that won't stay locked in position on a motor grader. So in the previous part, we got underway examining all of the components inside the valve section for the articulation function on this particular grader. We noted that there were 2 pilot-operated check valves, each with a tapered poppet. Springs that aren't shown in the schematic help to close those poppet-style check valves. We noted that there is one common piston up in the top section of the valve there that pilots open only one check valve at a time, and that is namely oil that is returning into the valve bank piloted from the side where pressure is occurring. And that's pretty typical. We talked about how it's a proportional valve spool. We talked about how there are pilot valves that are electrohydraulically operated. So let's continue on and think about troubleshooting a scenario where perhaps a particular articulation angle on the grader has been set. The operator is carrying out some grading operation, but somehow finds out that even though he's not working the valve lever, it's just an electronic joystick in this machine, even though he's not working the valve lever, he's finding that the cylinders are drifting out of position and he is coming out of the desired articulation angle that he had in mind. Now, of course, we could definitely be watching for any external leakage, any oil coming out of the cylinder into the open from the rod, from a fitting, from a leaky hose somewhere between the valve and the cylinders. That would always be our first point of attack. But assuming that everything is intact, there is no leakage out of the system, a key component for us to become highly suspect of is the pilot-operated check valves. Their designated function is to be a very positive lock for fluid between the directional valve bank and the cylinder. They are there to make sure that there is no bleed back of fluid from the cylinder back into the hydraulic system through a spool type of valve. A spool is a cylindrical object. Looking at the cutaway here, it's a cylindrical object inside of a cylindrical valve bore, and the wear that occurs over time can make this type of valve become more leaky, and that could be very undesirable for any cylinders that need to remain positively locked. So pilot-operated check valves are pretty typical to see there. So what could be occurring inside the valve that allows field forces acting against the cylinder rod one way or the other? What could be happening inside the valve that would allow those cylinders to continue to move when they should be sitting still? So if we go over to the pilot-operated check valves, we're expecting a very positive seal on the tapered poppet and seat, and it is always possible that in the moment when we go to close the valve to center, that a chunk of debris, perhaps a piece of piston seal, a shaving of steel coming from inside a worn cylinder, could come to rest on the poppet and seat. And that could be allowing the cylinder to continue to exchange fluid with a valve, even when the valve is at center. And why would the fluid from the cylinder continue to exchange or come and go from the cylinder? Well, for that, we need to have a look again at the spool and notice that the main cylinder line on the left side here passes right through the spool and is connected to the return to tank line on the right side of the valve manifold. Let's follow the cylinder line on the right and see where it goes. Same thing, passes through the valve spool and down to the return to tank line. The only main line that is blocked at the spool itself by this little T shape here on the yellow pressurized line, that's pump flow being brought to the valve if needed, and that is cut off when the valve is in neutral, but the tank and the 2 main cylinder ports are open and connected, and so it is a float center valve in essence, even though the pilot-operated check valves are there to keep us locked. So if the pilot-operated check valves fail, then by looking at the symbol, you could see we would be in float mode. The cylinders would be free to move from any field forces that occur. Okay, that's it for part 2. In part 3, we'll look at a few more issues about troubleshooting, and then we're going to switch over and have a look at a different section of the valve bank in this particular grader. Watch what happens to the piston here at the top, that single piston that we know of that does piloting. Watch what happens here. Watch the valve spool, the length of that valve spool and the symbol. as we switch over to a different section, namely the blade lift, things really did change there.